Okay, so guys, the question was basically asking what is the area, how do you, the equation for finding the area of an object, which is what? Length times width, right? So if I have a square or an object and I want to find the area of it, okay, so you just end up taking your length times the width. Now, with plywood, what it's sold in is in feet, okay, in square feet. So if I had this object right here, okay, I take 1 foot times 2 foot times 2 feet. How many square feet is this object? 2, right? Because I just take 1 times 2. That gives me a total of 2 square feet, right? Okay, so plywood is sold in square feet. Why would you assume that plywood's sold in square feet? What's that? Because it just is.
Yeah.
Okay? How many dimensions did we deal with for solid lumber? 3, right? We dealt with the thickness, we dealt with the width, and we dealt with the length, right? Can you just close the door, please? So for solid lumber, we deal with thickness, we deal with width, and we deal with length. Okay? So for plywood, going back to dealing with the planer and the joiner, do we ever planer joint plywood?
No.
No. Okay? So what dimensions do the planer and joiner deal with?
They deal with
Thickness, right? Okay. So since we don't ever joint plywood, we don't ever joint or plane plywood, are we going to deal with the thickness of plywood?
no.
No. So thickness of plywood, if I want a piece of material that's 3/4 of an inch, I'm going to buy a sheet of plywood that's 3/4 of an inch. Okay. If I only need a 1/2 inch thick material of plywood, I'm going to buy a sheet that's a 1/2 inch thick. Okay. So what we're going to do is for plywood, we're going to be dealing with just the width and the length. Now, what was one of the benefits of dealing with plywood rather than solid lumber? Doesn't warp, right? If you guys remember that on our bill of materials for our solid lumber, we had our rough dimensions, right? We had, this would be like our finished dimension, then we had our rough dimensions. We added a 1/4 inch for thickness, 1/2 inch for width, and 1 inch for length. Why did we end up adding those rough dimensions again?
So we mess up, we can, I think if we mess up, we can like kind of do it at.
It's not necessarily if you mess up, right? It's like if the board is warped at all, right? So we had cup warp along the face, and that's why we jointed it. So we got that face smooth. Okay? So basically, we had our rough dimensions because the board warps, or solid lumber has a tendency to warp. Since plywood doesn't warp if it's stored properly, okay, or very little at all, since it doesn't warp, are we going to need our rough dimensions at all? No. Okay? So if I have my sides here that say that my long side is supposed to be 1 foot by 2 foot wide, do I have to end up cutting this one to 1 foot 1/2 inch? And then cut it again to 1 foot?
No.
No. Because all you're gonna do is you're just wasting time. Okay? You're just taking an extra step. Okay? And our material isn't that wide to begin with. So what you end up having to do is basically you're gonna cut your sides to the final dimensions. Okay? So on the final dimensions, that's how they're going. That's all they're going to be cutting. So you don't have to deal with thickness or width at all. Talk a little bit more about dealing with that tomorrow. Okay, so tomorrow we won't be in the shop since it's a half day. So you don't need your safety glasses. But what I wanted to show you guys was the video for plywood, since that was supposed to be. I actually got 2 videos for you. To show. Right on that. What? Yeah, we'll be working. Okay, quick question. Why are they watering their trees?
To make sure it doesn't work.
Yeah, so it controls the splitting and cracking, right? So what it does, it keeps the moisture in the logs, okay, so it doesn't dry out as fast and end up cracking. Okay, that's kind of I didn't show you guys later, but that's what ended up happening to this chunk of board up here a kid was working with. It ended up adjusting to the humidity too quickly and ended up cracking. Okay, so that's why they're watered. It's not for it to grow. Why were the boards cut to just over 8 feet long?
Like there's the bad stuff higher too. When you're making like a house.
What's that?
When you make a house, you put studs in there 8 foot long.
Yeah, because sheets of plywood are typically sold in 4 by 8 feet. Okay, so a sheet of plywood is 4 feet by 8 feet, so they're cutting it just over 8 feet, and they'll get it the final length later. Okay, so this is basically a rough cut. Why are they promoting the use of all their scrap? Going green. Going green, yeah, it's a big thing. Okay, so what this will be turned into is either basically bio waste, so they'll either burn it right on site to heat or to create energy, or they'll sell it to like pellet stores. They don't have pellet stores here? Okay. It's like a wood burning stove, but only they use pellets instead of logs. It's all green. Okay, so this is pretty cool. It's peeling, so what they do is they actually take it and basically unroll the log, and that's how you get those grain patterns. Like if you guys ever look at your cabinets, if you have plywood cabinets, especially like along the sides, like if this is the kitchen, but my desk is the kitchen, this is the countertop, and if you look along the side right here, it has like the same pattern, like every couple inches or so, about every 10 inches, foot and a half or so. It's because it's the same spot on the log as it's unspun. You'll see this here. So you can see it's just a big blade, and what it's doing is shaving it off. So that's what it ends up creating. What are these gaps in here from?
Where
the log was uneven.
Where it was uneven, right? So you saw that last one, how it's kind of bowed a little bit. So what that does is they either make that for cores or they kind of just scrap it, like those first parts will just scrap out. But then once you can see here, once it's solid, okay, that's your finish face, your veneer, okay?
What about that one, does that make that centerpiece that you cut out the rest of the way, with that make like a dowel or something?
That, it could very well be. I guess it all depends on the manufacturer.
How thick are they making these boards?
What's that? How they cut?
No, how thick could they make them?
Probably only about a 1/16 of an inch or so.
Pretty bad.
That's one of the downsides though with plywood as you have veneer. Okay, so again, it's just that thin top layer. If you end up sanding too much, you'll sand through the veneer and you'll end up seeing the core. So basically the veneer is the nice stuff, okay, or your finished surface. If you sand through that or end up cutting through it, okay, you're gonna see it just like on the edges. That's why, part of the reason why we have the edge or the trim on the corners on our box to end up dressing up and hiding the actual core of our plywood. Okay, just like here, on this countertop or even on the tables. Like some of them, they're starting to peel off. But if you're to peel that away, don't try it, only if there's some there, okay? You'll actually be able to see the underside of the material. Yeah, like that corner right there, so find your way out, you guys want to. So here they're just stacking the cores in alternating directions. So like right now, the grain pattern on these ones are going from, I guess you say man to man, and this one is going, the grain pattern from the core section is going this way, okay? So this is just skill labor, again, trying to make this, if you guys were to look at this for money making, where's the money to be made? It's in setting up the machines, it's in basically programming the machines or maintaining the machine, like troubleshooting the machines.
So not this job, then
This one, I'm sure they make decent money, okay? But it could be, I'm sure they probably make 14, 15, maybe even 20 bucks an hour, which isn't bad. I guess I'm not sure depending on their, but you gotta think, just watch, it's the same thing. Time after time. Okay? So it may not be a high retention rate, like you may not see someone there for 8 years. So here's where they're actually cutting it to the final 4 foot by 8 foot standing saw. So this guy here, like he would probably be making more money than the people that are actually stacking those cores, because he's actually in charge of quality control. He's a heavy equipment operator, most likely. Right. Yep, and then they just ship it to wherever it needs to be. Okay, so that's plywood. This other video that I wanted to show was something that I found just on Popular Science today, and it's pretty cool. It relates to. I just thought it was really neat. I want to share it with you guys. But we'll talk about how it relates to your research projects.
Can you turn it up?
Yeah. Sorry.
So this is how I'm going to do my shoelaces. Okay,
Oh,
at the
no.
moment, my hand's closed.
Okay.
So in
Sorry.
order to get hold of the shoelace, I give it a slight open signal. Then I come down. I get to the place where I need it to be. I give it a close signal. I do my thing with my left hand. I'm just holding it. Open signal. And then come back in, a close signal. And then pull. And just little things that you would normally take for granted. The simple act of dealing cards out, for example. There's something that I can do. So, when I'm going to make a cup of coffee, my jug's in this cup. And there's little things. The wrist doesn't flex, but it rotates. So what I tend to do is I've got the wrist deactivated, so activate the wrist, spin the wrist, which is a bit weird, deactivate the wrist, and now I pick up my jug. The good thing is now that the fingers are in this position, they hook in just nice into the side of the fridge, which gets me to open the lid and come out from there. I have a few comments can I do that? Guy in Hungary, he asked if I could do rock and roll. Yes, we can. Someone asked me if I could do the international single road rage. Yes, I can. And I can also rotate it full 360. One more chap would say that he thought it was hand, and all done with special effects. So, it's not fake, it's real, hand, stump, and stump. Lock and load, and back and ready to go away. It does make life a lot easier. Things from tying my shoelaces, getting dressed in the morning, making a drink, taking the dog for a walk. It makes life an awful lot easier with two hands. Next time you get dressed, for example, put your trousers on one-handed. Just don't use your left hand if you're right-handed, don't use your right hand if you're left-handed. But just try putting your trousers on with one hand. See how many moves and how many wiggles and how many different positions you have to get into just to get the trousers on. And you'll understand that having the second impact doesn't make life an awful lot easier.
Okay. Can't condone drinking. So, what I wanted to, the reason why is just because it is so, cool for the technology part of it, but like you could use this for your research article. So you could do something about, like how a hand normally works. So like the nerve endings and the muscles, how they work in conjunction. So you could do a paragraph there. You could talk about like how it's actually connected. So is it actually connected like right to his to the stump or to the nerves right on his arm, or is there something like an actual wireless chip somewhere attached to his brain? Okay, so there's a couple different ways of attaching prosthetic arms and whatnot. You can even have an article about phantom limb. You guys know what that is?
Oh yeah, it's where you think.
Not quite.
If you lose a limb, but then you keep imagining that you still have the limb.
Yeah. So what it does is your brain basically pictures that your arm is still there. So like if you end up losing your leg, a lot of times what happens is you'll have something like it's called phantom feeling. Okay, because your brain is still messages to that leg that's still it thinks it's still there, but it's not receiving anything. So it varies from situation to situation, but it could be something where like it gets cold all the time, or you feel like a tingling, or there's still pain. There's some situations they say that even it's like a telescoping feeling. So over time, it feels like their leg finally gets shorter and shorter until the brain finally realizes that it's not there anymore. So that's another thing that they're dealing with prosthetics. It's kind of cool though. That's been a lot of things have been coming up in the news lately, is trying to get the brain so that it's when it sends a signal to actually open and close. So when he's thinking open, that his brain is actually getting some response that, oh, okay, this is how far it's open. Because if you notice, he had pretty good control over how far open and close, how much pressure and everything that he had. Like when he said open, it didn't just go like, and all his fingers busted open, right? He had control over fingers, and you saw him. He was able to do move a couple at a time, move his thumb independently. The only thing that I don't know if he's still learning how to work with it. I don't know. I just saw this video and I played it. But when he did the rock on the horns, when he threw up the horns, okay, you saw him. He had to hold his pinky and thumb and then close it. So I'm assuming what it's kind of like is how we use these three fingers the most, right? Okay, and basically when we move our pinky and our ring finger, they kind of move in conjunction with our middle finger. So it could be something that he's still learning how to work those fingers. But it's pretty cool to be able to use all the different fingers. Like I know, yeah, there's probably some. So you can even have an article on like what are they doing to improve it so it actually does this motion instead of just like complete 360, which is it's pretty neat. But you know what I'm saying? It's well, I'm sure you'd still rather have two. But I'm saying it's gotten a lot. It's become a lot more advanced. Like there's a guy that I went to college with. He lost his arm in the war in Iraq, but what ended up happening is he actually had to use them all, like, if you guys know those people were just the basic prosthetics, all he had was, he was able to just do this. He had the prosthetic limb and then 2 hooks, and I believe it was something where, like, in order to open it, he had to roll his shoulder back, and in order to close it, he had to throw it forward. So it was all mechanical, it wasn't electrical at all, I'm pretty sure.
About it. Think about, how much you think it would be for?
Cost one? Oh, I don't know. I'm sure a lot of it, yeah, I'm sure a lot of it is, he might be getting some funding, or, some tax cut, like if he's the first one to test it out, like on the research, if he's the research part of it, yeah, basically like the human being, so he probably goes to the clinics. But, like I said, it's something kind of cool, think about relating it back to your research article.